Jai Hind, all of you. I am Dr. Anand Tyagi from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to deliver my lecture on Engineering Mathematics First KAS 103. Before it, we have done some lecture of this topic. I explain and recall of previous lecture. In the previous lecture, I explained how to calculate characteristic equation of a square matrix, how to calculate eigenvalue, how to calculate eigenvector of a square matrix. Today we discuss some most important problem arises in the competitive exam such just like a GATE and CSIR, and discuss the next topic based on the matrices module 1. Right, today contains characteristic equation. I again recall what is the characteristic equation and how to calculate very short duration of time characteristic equation of a square matrix, eigenvalue and eigenvector. Right, this is just recall, and new topic is diagonalization of a matrix. How to diagonalization of a square matrix I discussed today in brief. And next is CAYLEY-Hamilton theorem. This is very most important theorem. What is the role of CAYLEY-Hamilton theorem in our engineering and technology? I elaborate in the end of the lecture. And after this, exam based on the above topic. So today we discuss very briefly each one of them, the contents today, and all of these contents refer from the book AKGEC Advanced Engineering Mathematics, Maurice D. Weir and B.V. Ramanna and B.S. Grewal, and student can be follow one of them. Right, now question is that how to calculate the characteristic equation. I recall it again because some student have a query, sir please remind the method how to get the characteristic equation very short duration of time. So suppose I write any equation, suppose I write here 1 0 minus 1, 1 2 1, 2 2 3. Right, this is a square matrix and I want to calculate characteristic equation of this equation direct without any explanation, very short duration of time. So first of all I write here lambda cube, right, minus lambda, and that is trace. I explain what is trace. Trace is the sum of diagonal element, right, this is lambda square plus lambda, right, and that is determinant of P. I explain what is P, determinant of Q and determinant of R here, right, and minus determinant of A here, right. This is the short method to calculate the characteristic equation very short duration of time. I have not requirement of explain this because due to some new student I explain it again, right. I write here lambda cube, right, minus lambda square, and what will be the trace of this? So trace is sum of diagonal element. So 3, 2, 5 or 1, 6. So I write here 6, right, plus lambda here, right, and what is P? P is the minor of order 2 by 2 which contain diagonal element here. So this is first 2 by 2. So what will be the determinant of this? 2 minus 0, I write here 2, plus second is Q. Q is the determinant which contain diagonal element. 3 2 is 6. 6 minus 2, that is 4, I write here 4, plus, and next is all corners point, this and this, 3 1 is 3, minus 2 plus 5, so I write here 5, and minus determinant of this square matrix of order 3 by 3 will be 6 here. I explain a method how to calculate determinant of a square matrix in short duration of time in the previous lecture. So what will be the characteristic equation here? Lambda cube minus 6 lambda square minus 11 lambda plus 11 lambda and minus 6 is equal to 0. This is characteristic equation of given square matrix. So student can be obtained in minimum time without any calculation this directly. Right, suppose I want to calculate factor, so factor will be the eigenvalue, right. So first right, there will be 3 eigenvalue of this equation because this is a cubic equation. So what will be the factors of this, right? So first vector can be calculated here. Suppose I write here 1, so 1 minus 6 plus 11 and minus 6, so answer is equal to 0. So that means out of 3 I got 1 eigenvalue, that is lambda is equal to 1, and I will get the all remaining eigenvalue. I explained it in the previous lecture. Now question is that, right, how to obtain any problem and how to solve such type of problem. I have a problem, find the eigenvalue and then eigenvector. How to calculate? So first of all we get the given matrix is A, and how to obtain the characteristic equation? This is known as characteristic equation. Determinant of A minus lambda I, that means from the diagonal we subtract a variable, that is lambda. So what will be the new result here? The result will be, so from the diagonal, right, I subtract minus, so this will be the, but question is that how to get this without any calculation, right? So with the help of this, so first of all I got the determinant of this in short method, right? How to explain? In the previous lecture I explained how to get the determinant of a square matrix in minimum time. How to get? I reply here, right, and recall, just I write the given matrix, right, 4 and 2 and minus 5 and 3 and 2 here, right. So suppose, right, I write here and first two column repeat again. So what will be the first two column? The first two column will be here, I write here, right, minus 3, 2, 1, minus 7, 4 and 2, right. First of all I cross this, so what will be the value of this? 4 3 is 12, minus 2 24, so minus 24, student remember it, and 7 3 is 21, right, and 5 2 is 10, 10 2 is 20, and this will be is equal to minus 65, right, minus, right. Now this I 7 2 is 14, 14 2 is 28, minus 3 3 is 9, 9 2 is 18, minus, right, and this will be is equal to the 5 4 is 20, minus, this will be minus 66, right. So result will be here, right, minus 65 minus minus plus 65, so determinant of this square matrix will be 1 here. If student have a practice, it can be obtained 10 and 15 seconds only, there is no requirement, so, right. So that means in this way we find the determinant of any square matrix 4 by 4, 5 by 5, we can calculate from this method, right. Now question is that how to obtain this? So how to obtain? I have right here lambda cube minus, right, trace. What will be the trace? Right, 4 to 6 or 6 minus 3, 3. So I write here 3 lambda square, right, plus lambda, right. There are three different. So first is this, right. So what will be the determinant of this? 4 3 is 12, minus 12 or plus 14, so 2, right. And second is this, 4 2 is 8, 8 minus 6, so 2, right. 4 or last is 1, 3 3 is 9, 5 1 is 5. So this will be is equal to 3 sum, right, minus determinant is equal to 1 is equal to 0. So this will be the equation of this lambda cube, 3 lambda square, 3 lambda minus 1 is equal to 0. So this is the method to obtain the characteristic equation of given square matrix. Now first of all we get the characteristic roots of this equation, and roots are 1 1 1 here. Students see very carefully, the roots are equal, real, right, we can say roots are real and repeated. So there may be 3 eigenvector, there may be 2 eigenvector, there may be 1 eigenvector. This is depend on our calculation. So how to calculate, right? Next, eigenvector at lambda is equal to 1 here. So first of all I get here, right, A minus lambda I, x is the corresponding eigenvector x y z, maybe x1 x2 x3 here, right. And how to calculate, right, we see that first row, second row and third row, there are 3 rows and 3 rows are different, that means unidentical. So that means solution will be any one of 2, right, maybe first second, maybe second third, and maybe first and third, and result may be same, right, either first or second, either second or third, either first or third, result will be same here, right, because all 3 rows are different. So we consider here I solve first two equation. So what will be the value of x? So x will be here, right, upon this, and y will be here this and this, and y be right there this. So result will be minus 6, minus 2 and minus 1. Suppose I want to calculate here, so what will be the result if I divide this result from minus 3, so result will be minus 3 minus 1 1 here. So how to check that this is correct or not? We can check with the help of this equation, right? But question is that suppose any student can say that I wants to solve here second and third. So what will be the result here? I solve here, suppose x upon, I write here, right, x upon, right, I here solving second and third. So what will be the result, right? 3 2 and 3 1 here is equal to minus y upon, right, y means 2 1, I write here, and 3 1, and is equal to z upon, what will be the result, 2 1 and 3 2, right? So what will be the result here? So x upon, what will be the result here? 3 1 ja 3, 3 minus 6 minus 3, I write here minus 3, minus y upon, right, 2 1 ja 2 minus 1, so I write here minus 1 is equal to z upon 2 2 ja 4 minus 1, right? Now question is that what will be the eigenvector here? Is equal to x1 is equal to, I write here k, right? Suppose minus 3 1 1, right? So this will be the our eigenvector. Suppose any student can say that sir I wants to solve first and third, result will be same here. So that means there are only one eigenvector exist for lambda is equal to 1, because lambda is equal to 1 are equal, right, arises equal 3 times. So that means there exists only one eigenvector, right? Suppose any calculation, after the solve the calculation, first row, second row and third row will be same here, right? So solution will be any one of them, right? Solution will be any one of them, and there exist 3 vector for the eigenvalue lambda is equal to 1 here, and all 3 vector calculate with the help of first row, right? So student keeping in the mind when we solve such type of problem, so we can say that we calculate our result, right? Suppose I have another problem, find the eigenvalue and eigenvector of the given matrix, right? Given matrix is this. So how to calculate here, right? So we get here, right, first of all characteristic equation, how to get it? So first of all student determinant of this, so determinant of this will be equal to 4, right? Now question is that how to get, so lambda cube plus trace 2 2 4 1 5, I write here 5, next after this 2 2 ja 4 4 minus 2 0 4, 2 2 ja 4 4 minus 2 2, right, and 2 1 ja 2 minus this is 4, so 5 or 3 8 or 3 8, so I write here 8, and determinant of this is equal to minus 4, so I write here, right? So student can be solved with the help of direct without any calculation. Now question is that these roots are correct or not, right? So I explained it in the previous lecture, right? Suppose sum of the eigenvalue 2 2 4 1 5 is equal to trace 2 2 1 5, and another method, product of eigenvalue 2 2 ja 4 4 1 ja 4 is equal to determinant, and the determinant of A is equal to 4. So that means our result is true. Now question is that roots are, one root is, right, alone, and 2 roots are repeated, right? So first of all we get eigenvector at lambda is equal to 1, right, and then we calculate eigenvector lambda is equal to 2 here. So first of all I calculate lambda is equal to 1 is the eigenvalue, and we calculate eigenvector here. So what will be the result? A minus lambda I is equal to x1. So how to calculate it, right? So we calculate here, we put the value of lambda is equal to 1 in this equation and check that there are 3 rows, first 2 rows are same, that means solution do not contain with the first and second, that means solution will be exist first and third or second and third here. So we solve here second and third row, right? How to solve second and third row? I explain here one by one, right? So x1 x2 x3, right, with the help of x1 I hide these terms and this consider, right? So in this way we can find out, right, the solution of 1 2 1 1 here, right? X2 0 minus 1 1 1, x3 is equal to 0 minus 1 1, so solution will be minus 1 1 1. Suppose I divided minus 1, so what will be the solution here? So solution will be 1 1 minus 1k here, in this way, right? As student can be right here minus 1, right, and 1 only, right? In this way we find the first eigenvector at lambda is equal to 1 here, right? Student keeping in the mind. Now we check what is the eigenvector at lambda is equal to 2 here, because 2 and 2 are the repeated root. So first we calculate lambda is equal to 2 here. So I got the result a minus 2i x2 is equal to 0 and x2 is equal to x1, x2, x3 here, component of this. And how to calculate here? So what will be the result here? Solving first and second row, because first row and second row are not same, so we can solve first and second here. So we got here, right, x1, x2 and x3 here. So what will be the result here? So result will be this. So in this way we find the second eigenvector corresponding to the lambda is equal to 2. Now question is that what will be the third eigenvector? Third eigenvector is exist or not here. So we see here, right, suppose any student can be say that, sir, I solve second and third equation and we solve first and second solution, so result will be same here, right, because three rows are unidentical, first, second and third here, right. So in this way we can say that third eigenvector corresponding to lambda is equal to 2 does not exist here. So only two eigenvector is exist here. So in this way we find out how many eigenvector exist or not. Now question is that what is the role of eigenvector? So eigenvector is depend the designing and the balancing, and we can say that eigenvector is the most important role for searching. When we search any kinds of information on Google's, so then Google's play the most important role for searching with the help of eigenvalue and eigenvector. Now question is that if n linear independent eigenvector, then A is not diagonalizable, right. How to? Suppose I have a matrix but eigenvalue is exist, right, 1 1 1, but eigenvector exist only 1, right. So that means it is not diagonalizable. In this case how to solve, right, the diagonalization? If there exists a set of L linear independent vector, so we can say given matrix will be diagonalizable. How to? Suppose x1 is the corresponding eigenvector at any value of eigenvalue, x2 is another eigenvector and xn is another eigenvector. So we can get a model matrix P. How to? So model matrix P I explained in the previous lecture, first eigenvector will be first column, second eigenvector will be second column, and third eigenvector will be third column, and nth eigenvector will be nth column. So we prepare here a model matrix P here, right. Suppose there does not exist n eigenvector, so P is not possible and P is not possible, so it is not diagonalizable, right. So this is diagonalizable only when we calculate the n eigenvector. Suppose we have a 3 by 3 matrix, so that means there exists a 3 eigenvalue. If 3 eigenvalue is exist and 3 eigenvector is exist, then we can diagonalizable of this matrix. How to? I give in the example, right. Diagonalizable matrix D is equal to, that is very most important, P inverse AP. What is the role? I discuss here, right. Here P inverse is the inverse of P. How to calculate inverse? I explain it previous lecture, and student study in 12th level how to calculate inverse of a square matrix, right. Now question is that what is the role of this phenomena? The result of this phenomena is this very most important. Suppose I wants to calculate, right, D2, right, yeah, D3 and Dn. So with the help of this result we can calculate the our requirement, right. How to? This will be later on, right. We discuss here, right, what is the role of such type of problem, and in this method we can find the inverse of a square matrix. This is the requirement of our calculation. So I write here most important result. Suppose I want to calculate any kinds of power of a square matrix, then we can calculate with the help of this. We calculate here after the Cayley-Hamilton theorem. This is very most important. I discussed some problem arises in the gate 19, gate 18 and gate 20 here. So what is the role of such type of problem? So I explain here, find the model matrix P, right, which diagonalize the matrix. This is given matrix, this is a square matrix. So first of all I wants to calculate here, right, characteristic equation of this matrix. So we can calculate the characteristic equation of this matrix. We can calculate directly characteristic of equation of this matrix. How to? Right. So lambda square minus trace is 7, so 7 lambda, and plus determinant of this 4 3 is 12 and 12 minus 2 right, is equal to 10. So this, so we can calculate that without any calculation within second, right, characteristic equation this, right. So what will be the factor of this? The factor will be 2 and 5, right. 5 2 is 10 and determinant is equal to 10. So that means this is correct. But question is that our aim is diagonalizable of this, right. So first of all we get the eigenvector of the corresponding eigenvalue here. So what will be the eigenvalue? So first of all I can calculate the eigenvalue at this point, right. So with the help of 2 1 2 1. So two rows are identical, so calculation can be solved with the help of any one of them. So I got this result. Okay, first eigenvector is here 1 minus 2 and this is satisfy this equation, right. So I got the first eigenvector with the help of calculation. Now we get the second eigenvector, right, corresponding to the value, right, lambda is equal to 5, right. How to calculate? So this is the procedure, because last previous 2 and 3 lecture we have calculate different types of eigenvector corresponding to the eigenvalue here. So with the first and second row both are same, so solution will be any one of them. So with the help of first I write here minus x plus y is equal to 0. So what will be the solution which satisfy this equation? So solution will be 1 comma 1 here. So in this way we find out two eigenvector, and how to get the model matrix P with the help of eigenvector. So I write here, right, with the help of given this and this, right. So I got the model matrix P, first eigenvector and this is second eigenvector. First eigenvector first column and second eigenvector is second column. So this is the way to calculate the model matrix P. Now question is that how to calculate inverse, because this is a 2 by 2 matrix, so we can calculate directly without any calculation, right. I explained it in the previous lecture how to get the inverse of 2 by 2 matrix in short duration of time. So this is very easy method. Diagonal element are interchange, so I interchange, so that means both are same, right, and there is sign minus 1 and there is sign minus 1. So I write minus 1 and minus plus here, right, and divided by determinant of P, right. So question is that what is the determinant of P here? So 1 1 ja 1 and plus 2, so determinant of 3. So this is the method, short method to obtain inverse of 2 by 2. Student, keeping in the mind we can save our time in the examination by using such type of method. So that is very most important method. We can use the direct method and minimize the time in the examination. We can calculate the inverse. I repeat again, right. First of all replace or interchange the diagonal element. I interchange, suppose there is 1 and 3, so I write 3 and 1, and non-diagonal element rise a minus sign I write and divided by determinant of a square matrix. So this is the method to obtain P inverse directly. Now question is that how to diagonalizable. So first of all we calculate P inverse AP here, right. So this is P inverse, this is A and this is P here. Suppose I want to multiply all of things, right. So result is very beautiful, right. What will be the result here? So result will be this, right. That means this, right, on the diagonal eigenvalue exists, and right, and our eigenvalue was 2 and 5 here, right. So this is first eigenvector corresponding to the first eigenvector and this is corresponding to the eigenvector. That means diagonalization will be the result of our eigenvalues, right. This is the beauty of this mathematical portion, right. So this is very most important for the searching, right, and the neural network programming. This is very most important, right. So in this question we discuss how to diagonalize the given square matrix. Here we discuss, right, how to diagonalize the 3 by 3 matrix, right. Suppose I have a matrix of order 3 by 3. So first of all student find characteristic equation very short of duration time, that means very fast. How to get here? So first of all I want to calculate determinant of this, and characteristic equation will be A minus lambda I, and I subtract lambda from the diagonal, and this work will be very fast. Now how to obtain this? So square, right, determinant of this will be 6 here. Student can be calculate direct, right. How to, right, calculate the characteristic equation, right. First of all I write here lambda cube, I write here lambda square trace. So what is the trace? So trace is equal to 2 1 3 and minus 1, that is 2. So I write here 2, right. Now this terms, this is the 3 component P Q R, and P is the this always fixed in 3 by 3. P is fixed, Q is fixed, this is Q, and R is corner element 2 3 minus 1 1, right? So determinant of P is 2 1 ja 2, 2 or 2 4, right? And next 1 minus 1 or minus 3 minus 4, both are cancel out, right? Next minus 1 or minus 3 minus 5, right? So I write here minus 5. First sign positive, second negative, positive and negative. I consider this sign, and minus determinant of this, or determinant of this is equal to minus 6. So I write here minus 6. So this is the criteria, right? This is the method to obtain direct characteristic equation. We save our time in the examination and we can calculate directly and check that this is correct or not. So I have a root here, lambda is equal to 1 3 minus 2. So how to check? Determinant is minus 6 and product is minus 6, correct? Sum of determinant is sum of eigen value 3 1 4 minus 2 2, right? And this is also 2, right? So we can say that these are correct. So in this way, so roots are real and different. So we can calculate eigenvector at lambda is equal to 1 3 minus 2 separately. So first of all, I calculate eigenvector at lambda is equal to 1 here, right? Minus 2 here, I calculate this minus 2. So with the help of minus 2, when we write minus 2 here, right? So I write here 4 minus 2 3, 2 minus 2 4, 1 minus 3 3, and minus 1 minus 2 1 here. So this is first row and this is second row and this is third row. There are 3 row and 3 row are different. So solution may be first and second, solution may be second and third, solution may be first and third, but it will be unique. So I solve this first and second here, right? And how to solve, right? Minus 11 1 and 14 here. So in this way we got the first eigenvector corresponding to the lambda is equal to minus 2 here, right? So I write here 11 1 and minus 40. This is the first eigenvector, right? Now calculate second eigenvector at lambda is equal to 1 very fast, as well as in the process in previous value, right? I got first and second row are not same. Yeah, we can say that first and second row are different. So solution will be first and second here. So we can solve with the help of x1 upon this, right? x2 upon this, this and this, and x3 upon this, right? So in this way we can find the, and divided by minus 2 here. So what will be the second eigenvector here? So second eigenvector will be 1 minus 1 minus 1 here. Yeah, student can be right here, right? minus 1 1 1 here. These both are same, right? Or by this. So in this way we can find out our result here, right? So what will be the result here, right? So in this way we find out the next eigenvector at lambda is equal to 3 here. How to? So this is the procedure to calculate our result. This is third eigenvector. Now we find the model matrix P here, right? I write here first eigenvector, second eigenvector and third eigenvector. This is known as model matrix corresponding to the given eigen value. In this way we find out inverse of this by using any kinds of method. I explained in the previous lecture, right? We have more than one method to obtain the inverse of this, right? Student can be used direct method, right? What will be the this? So this will be a11. So a11 means this and this. So result will be minus 1 and minus 1 minus minus plus, and this will be 0, right? Suppose I want to calculate a12 here, right? a12. So first row second column, right? minus 1 1 1 minus 1 minus 15. So I write here, right? So in this way we can use directly without any calculation P inverse. Now question is that our aim is calculate diagonalizable P inverse AP here. So first of all we product this and this. In the previous lecture I explained how to product first and second matrices. So this is product by this, and what will be the result here, right? So will result here, right? Calculate here, right? So result will be this, product of this and this will be this here, right? Right, in the previous lecture I explained how to product two matrices, right? So suppose element of this is a11, so first row and first column is multiply and write here, right? In this way we find out the next value, right? This will be first row multiply by first column. So what will be the result here? We see here 0 multiply by this 0, 2 2 ja 4, 28 2 ja 56, and this result will be 60 here, right? Similarly I want to calculate this, so this will be result, this will be 0. That means first row multiply by this, right? 3 2 ja 0, 3 minus 2 minus 6 minus plus 6 0 here. Suppose I wants to calculate this result. So how to calculate, right? So that means, right, second row multiply by second column. So result will be minus 30. How to got this, right? So third row multiply by third column. So result will be minus 30 and divided by 30, right? So what will be the result here? That is most important result, right? This is first eigenvalue at lambda is equal to minus 2. This is second eigenvalue and this is third eigenvalue, and this is known as D, diagonalizable. That means given matrix is diagonalizable here. So in this way we can find out the diagonalizable of given element, right? A given matrix. So in this way result will be very beautiful. All diagonals element will be on diagonal hand and non-diagonal element will be 0, right? So in this way we can calculate our result by step here, right? Suppose next is CAYLEY-Hamilton theorem. This theorem is very most important, and what is the role of this theorem we explain here, right? And utilization of this engineering and technology, right? Every square matrix satisfy its own characteristic equation, right? Every square matrix satisfy on its characteristic equation. In the just now I recall how to obtain the characteristic equation, right? Suppose I give an example here, right? A is any square matrix and its characteristic equation may be anything, right? I write here this characteristic equation is this, right? So suppose this square matrix A satisfy this, so in that means in the place of lambda we put A and result of this will be 0 here. So this is known as CAYLEY-Hamilton theorem. So I write here, right? So by using CAYLEY-Hamilton theorem by A, so result will be here A cube 2A square, right? And minus 5 plus 5A and minus 6I is equal to 0. If result is 0, that means CAYLEY-Hamilton theorem is verified. But question is that what is the role of CAYLEY-Hamilton theorem? The role of the CAYLEY-Hamilton theorem is to get the inverse of A square matrix in short duration of time, very short duration of time, right? So how to multiply by this A inverse, what will be the result here? So result will be A cube multiply by A inverse, the A square, 2A square A inverse 2A, 5A into A 5I and 6I is A inverse. So we multiply by A inverse. So what will be the A inverse here? So A inverse is equal to 1 by 6 A square minus 2A plus 5I A, right? So in this way we can calculate very short duration of time, right? How to get the inverse, how to get the power of a square matrix. So in this way we can find the very short duration of time. Now we discuss here a question, verify CAYLEY-Hamilton theorem, A is equal to this. So how to get, right, the result? This question arises in the GATE exam in the form of, right, how to, right, we discuss here, right, verify CAYLEY-Hamilton theorem and obtain the value of A raised to the power 8 here, right? So we discuss here just now, right? The question is that, right, what is the role of CAYLEY-Hamilton theorem? We discuss here that first of all we calculate the characteristic equation here, right? How to get characteristic equation here? So A minus lambda I is equal to 0, and right from the diagonal we subtract it. Yeah, we can calculate directly. How to? So lambda square minus trace is equal to 0, so 0 lambda, and plus determinant of this minus 1 and 4 is equal to minus 5. So we can calculate here lambda square minus 5 is equal to 0 here. So this is the characteristic equation direct without any calculation we can calculate here, right? So this is our result by the calculation. So result is lambda square minus 5 here. So we can calculate with the help of calculation, yeah, with the help of direct method, any one of them. So lambda square we can calculate here, right? CAYLEY-Hamilton theorem, lambda is equal to A here. So what will be the lambda is equal to A? So A square is equal to 5I. That is most important criteria. Lambda is equal to 5. Suppose I want to calculate here A raised to the power 8. So what will be the A raised to the power 8 here? Suppose I want to calculate here A raised to the power 8, right? So what will be the result here? So 5I raised to the power 3 here, 5I raised to the power 3 here, right? So 5 raised to the power 3, 125. So result will be 125I. Right, so this is the very most important question arises in the GATE, right? So we can solve it without any calculation. Problem is A raised to the power 8 we calculated, first calculate A square, then A cube, then A5, A4 and A5. That means it consume a large time here, right? So in this way we find out the whole problem based on the characteristic equation, right? In this way we find out A square, right? And now we find out the suppose this is verify or not. So a square minus 5i is calculated a, right, 5i, right, and this is calculated with the help of this. So how to obtain here? So Cayley-Hamilton theorem is verify here, because right hand side should be 0 here. So we can say that Cayley-Hamilton theorem is verify here, right. So what is the role of, suppose I want to calculate inverse of, so we multiply by A inverse. So A inverse will be here, A inverse is equal to 1 upon 5 of A, right. So how to get A is the this matrix. So we can check that this is correct or not, right. So we can check here, diagonal element are interchange, and no diagonal element multiply by -1 and divided by the determinant of A. So we can check here this is right. In this way we can find the inverse of a square matrix. In this way we find out the whole problem based on the characteristic equation. Suppose this is A and verify the Cayley-Hamilton theorem, find A inverse. This is very most important problem, arises many exam, competitive exam and subjective exam, right. How to get this value and how to get this value, this is very most important. So first of all we calculate here characteristic equation in the previous method, right, direct or calculation. So I got this equation, this is known as characteristic equation, lambda cube trace PQR, sum of PQR, and this is determinant of A. That means determinant of here is P is equal to 4 here. So in this way we find the value of characteristic equation. We have no requirement to factorize this, but we first of all we Cayley-Hamilton theorem verify here. So in the place of lambda we put lambda is equal to A here and calculate A cube, A square, A and 4i. How to get? So this will be the result A cube, right, this is result A cube. First of all I got A cube, then A square and put the value of here, right. So in this way we find out the characteristic equation. This is the method to calculate the A square. A multiplied by A, I explain here briefly, right. That means first row multiply first column, 2 2 ja 4, 4 1 5 or 1 6, I write here 6, right. So in this way we can find very fast method to A square. If I want to calculate A square, so it will be A square into A. So A square is this and A is this, we get A cube here. So in this way we find out all the values very fast with the help of calculation and see that this will be equal to 0 here, right. How to? I explain here, right. 22 minus 36, right, plus 18 and minus 4, this is will be equal to 0 here. We can check each and every calculation here for the verification. In this way we find the all values Cayley-Hamilton theorem is verified. So this is very easy but calculated, right. In this way we find out inverse of the square matrix. How to get? So this is our Cayley-Hamilton equation which satisfies just now, multiply by this by A inverse. So this will be the result, and how to get the result of A inverse will be this, and A inverse will be here, A inverse is equal to this. So what will be the result of this? I just calculate it. A is the given matrix, I is the identity matrix of same order of the given matrix. So I write here this. So what will be the calculation of this? So calculation will be here this, and this will be the inverse of given matrix. So in this way we find out the value of our problem. So in this way we find out the value of our given problem. So in right, suppose I want to calculate this. So first of all we check that which is common part from here, right. So which is common part from here? So common part is right. So common part is here this, right, A cube. So suppose I want to take the A cube, right. Now our aim is reduce the in the given, right, get it, we get the characteristic equation just now. So A cube multiply by A cube, A6, right. This is our characteristic equation, right. By force or easy method we calculate here the characteristic equation in between, right. How to? A cube multiply by A cube, A6, A3 multiply by this, so A5, right. A cube multiply by this, so A4, A cube multiply by 4, so that is 4A cube here. So I write 2A cube here and 2A cube here. So this is justify. In this way 12A square, so I write 2 into 6 12A square, 2 into 9 18, so remaining is 5, I write here 5A, right. In the between 2 4 ja 8, so 8 1 9. So that means in this way we use the characteristic equation. With the help of characteristic equation we will reduce our given part. So value of this will be 0, I prove it. Value of this will be 0 here, I prove just now. So what will be the remaining terms? So remaining terms will be here, right. Remaining terms will be here 0 0, that is 5A minus I. So that means what is the value of this whole terms? the value of this whole terms will be 5a minus I here, and I know what is the value of a and I know what is the value of I, right? By putting the value of a and I, we get value of this. Suppose next problem is I wants to calculate this, right? So in this way, first of all I create the characteristic equation here, and this is characteristic equation. I create characteristic equation by force. How to? We get here, right? So a cube multiply by a5, a square multiply by 6a square, but I have 5a4, so I write here a4 here, right? So this is the method to obtain 9a, a square multiply by to 9a square, but this is a 6a square, right? So I write here 3a square. In this way we can get the our value, right? How to get, right? So value of this will be 0, value of this will be 0, and remaining portion will be a square minus 2a plus 2i here. So in this way we find out the all values of our characteristic equation, right? So this is the criteria to solve the our CAYLEY-Hamilton theorem and various problem based on our this, right? Verify CAYLEY-Hamilton theorem and find its inverse. This problem based on this topic. So in this way we find out our many problem and to solve the CAYLEY-Hamilton theorem. So today lecture we discuss how to obtain the characteristic equation, how to obtain the inverse. So with the help of CAYLEY-Hamilton theorem, that means we have many methods to obtain the inverse. First is A inverse adjoint A upon determinant of A. Second, PQR method, and this is known as CHT, CAYLEY-Hamilton theorem method to obtain the inverse of a square matrix. So I think today we have discussed about a lot of topic. If student have a problem, any kinds of problem, they can contact me, my personal number, and I will discuss with all student later on, right? And next lecture I will be discuss here any kinds of problem, right? So today thanks you all of you.